Measuring water vapor on a gas pipeline, which is very dry, has special requirements to avoid intrusion of ambient humidity from the ambient air. To sample out of a gas pipeline, you'll need a valve connected to some type of sampling device. The sampling device could be just an open tube, but we recommend using a bulb of this type, which could be made of either hard plastic like this PVC or preferably of stainless steel. The sample bulb has some outlet ports, a sampling port, and it screws into the pipeline using a standard pipe thread fitting. Okay. Before starting, do a leak check using an unopened tube on the hand pump. Start the sampling, crack the valve, and allow gas to flow for a minute or two to flush the bulb and fill it with dry natural gas. To get a good sample, all you need is a flow of about 1 liter per minute. Without a flow meter, a good rule of thumb is just put your hand over the bulb and you should be able to feel the flow without necessarily having a strong force of gas flowing. Don't allow the gas to flow too strongly or the expansion will cause a rapid cooling of the gas and the bulb. When you're ready to make the measurement, it's critical to avoid intrusion of humidity from the ambient air. Don't open the tube until just before you're ready to make the measurement. First break open the end of the tube that goes into the pump, because it doesn't matter terribly much if there's a slight intrusion of humidity onto this side of the tube. After that, we'll break open this end of the tube and then flip the tube around and insert the other end into the pump. Okay, now I'll demonstrate the whole process. It'll proceed very quickly. Open one end of the tube, then the measurement end of the tube, insert the other end into the tube, and the entire sample into the bulb. Take your 2 strokes. Wait for the end of flow indicator to indicate that your minute of sampling time is up. When the sampling is complete, rotate the handle 90 degrees, push the handle in all the way, and pull a second stroke. Make sure to align the dots on the pump and the shaft. Now you can see the color forming. The vacuum flow indicator is almost finished, and sampling is complete. It's been 1 minute. Remove the tube from the pump and quickly make the reading. And here we have 4 pounds per mmCF. You can see the reading is still 4 pounds per mmCF, but quickly the ambient air is intruding in and causing this purple color interference. So you need to read the tubes immediately. No matter what tube you're using, it's always a good idea to familiarize yourself with the tube sheet in order to be familiar with the number of strokes, the sampling time, the cross sensitivities, and temperature and humidity effects. For the water vapor tube, temperature can affect the readings. Here's a table of correction factors as a function of measurement temperature. To correct, multiply the value by the actual concentration observed on the tube. For example, if the reading is made at 86 degrees Fahrenheit, the correction factor is 0.73, and if you had a reading of 10 pounds per mmCF, the actual concentration would be 7.3 pounds per mmCF. Note that it is the temperature in the gas flowing that is most critical and not the ambient temperature. In wintertime, we recommend that you keep the tubes warm in a pocket until just before making the measurements. Also note, although it's not shown here, that the color tends to be darker, that is more greenish or purplish, as the temperature gets lower. Finally, it's always a good idea to check for possible cross sensitivities on the tube sheet. Although it is known that methanol can respond on the water vapor tube, here we see that less than 50 ppm of methanol shows no effect. A typical response when water and methanol are present together is to form a two-tone color, with the water forming the darker color and the methanol forming the lighter green color as shown here. In this case, one would read only the dark stain as the water concentration. However, when the concentrations are lower, it is often difficult to distinguish these two, and therefore one must take the total reading as the water concentration. Finally, heavy hydrocarbons like hexane show no response, and this is also true of triethylene glycol and other heavy glycols that are used in natural gas dryers. Therefore, there should not be any interference from such compounds. If you're measuring H2S on the gas pipeline, sampling time and procedures are not as critical because you don't have the ambient H2S to interfere. So I'm just going to open this at my leisure, find the inlet arrow, put it here into the pump, take my sample, this is a one-stroke tube, so we only need the one stroke. The end of flow indicator is complete, indicating the sampling is complete. You take the tube out, measure it. This happens to be a 0.5 to 7 ppm tube, and I see no color change. If there had been any H2S in here, it would have been changed to a pinkish color, but there's almost no color change at all. So we have pretty much zero H2S in here.